Hello and welcome to Earthquake Tip number 25. My name is Shailesh Kumar Agarwal, Executive Director of BMTPC, and I'm going to present to you all about earthquakes, its concepts, terminologies, and how to construct buildings and structures to withstand earthquake forces through 32 earthquake tips, which are authored by Professor C.V.R. Murthy, mentored by Professor Sudhir Kumar Jain, and developed by IIT Kanpur in association with Building Materials and Technology Promotion Council, that is BMTPC. Through these tips, our aim is to spread right technical information in simple to understand language to our professionals who are in the field designing and constructing structures, especially our architects and engineers. Before we start, let's make a pledge that any new structure we design or build must be earthquake resistant. This earthquake tip number 25 will explain you why are load paths important in buildings. Let's first understand what are load paths through this figure. Now we already know that earthquake ground shaking induces inertia forces in buildings at places where mass or weight is present. These inertia forces are transferred downwards through horizontally and vertically aligned structural elements, that is, beams, columns, shear walls, to foundation, which in turn transmit these forces to soil underneath. The paths along which these inertia forces are transferred through building are called load paths. As you can see in this figure 1a, building may have multiple load paths running between location of its mass and foundation. As you can see in figure 1b, it shows that load paths are as much a concern for transmitting vertical loads, that is self-weight, occupancy load, snow load, etc. Whereas, as you can see in figure 1c, these load paths are also a concern for transmitting horizontal loads such as earthquake and wind. Now let's understand the structural elements in the building which constitute load paths through this figure 1a again. First is horizontal diaphragm, that is also known as slab or floor. These horizontal diaphragm elements led in horizontal plane, that is roof slab, floor slab, or trussed roofs and bracings. Vertical elements spanning in vertical plane along the height of building, that is planar frames comprising of beams and columns interconnected at different levels, walls, RCC or masonry, and planar trusses. Third is the foundation and soil, that is isolated and combined footings, mat, pipe, and well foundations, soil layers, and rock. And fourth, the most important one is connections between the above elements. Buildings perform best in earthquake when inertia forces generated in them are transmitted to foundation by continuous and direct load paths without being bent or interrupted. When structural elements are discontinued along the direct load path, loads have to bend and take detours to other load paths. Therefore, buildings with discontinuous or indirect load paths are undesirable because brittle damage can occur in structural elements at these interruptions or bends. Now let's understand these structural elements one by one. First, floor and roof slabs, also known as horizontal diagrams. They are thin, wide structural elements laid in a horizontal plane at different levels. These transfer inertia forces induced by their own masses to vertical elements on which they rest. During earthquake shaking, these horizontal diagrams act like beams in their own horizontal plane and transmit inertia forces to vertical elements such as structural walls, planar frames. As you can see in this figure, they are long in plan, means flexible in their own plane, bend and undergo undesirable stretching along one edge and shortening along the other. If you look at this figure 2b, in general, slab should be rectangular with plan length by plan width less than 3. Slabs or horizontal diaphragm perform best when relative deformations are minimal and in-plane stiffness and strengths are sufficiently large. Another aspect of these horizontal diaphragms is openings. These horizontal floors can effectively resist and transfer earthquake forces through direct load paths, provided that they do not have significant openings. Large openings or cutouts in floors interrupt load paths and may prevent smooth direct transfer of forces to vertical elements. Openings in floors are necessary, such as to allow elevator or lift core or staircases to pass through. However, these should be as small as possible and as few as possible. Also, their locations should be carefully considered. The ideal locations for openings is close to the center of floor slab in plan. Now let's move to vertical structural elements. As you can see in this figure 3, typical structural elements present in vertical planes of building are columns, braces, and structural walls, or combination of these three. They collect gravity and horizontal and vertical earthquake inertia forces from floor diaphragms at different levels and bring them down to the foundation below. There are several structural systems which can be designed and constructed for earthquake resistant buildings, such as movement resisting frame, as you see in this figure 3a, frame with braced members called braced frames, figure 3b, structural walls also called shear walls, as you can see in this figure 3c, or we can have combination of these three. Some of these systems require more advanced knowledge of design and higher quality control during construction than others, as reflected by their relative performance during earthquakes. It is seen that buildings with shear walls are easy to design and construct and generally perform better during earthquakes than buildings with moment resisting frames. Means option 3C is better than other option. Having understood the role of various structural elements for load paths, let me spell out key requirements of load paths. Earthquake performance of buildings are determined by soundness of their load paths, independent of material with which buildings are built, that is masonry or RCC or structural steel. Earthquake codes require designers to ensure presence of adequate lateral load paths in building in two horizontal plan directions. Essentially, there are four requirements of load paths. Number one, load paths must exist in all directions of buildings, as we are aware that earthquake shaking occurs in all directions, and it can be expressed as combination of shaking in one vertical and two mutually perpendicular horizontal directions. Therefore, adequate load paths needed along the vertical and two mutually perpendicular horizontal directions. Two, load geometry must be simple. That means uninterrupted direct load paths should be provided at regular intervals along the length and width of building. Third, load paths must be symmetrical in plan. A building will sway uniformly in two horizontal directions when structural elements constituting load paths are placed symmetrically in plan. Otherwise, it will twist around a vertical axis, which is detrimental to its earthquake performance. Number 4 is robust connections are needed between structural elements along load paths. This is explained through this figure. In an earthquake resistant structure, every connection is tested during strong earthquake shaking by earthquakes. These connections should be strong and stiff to offer continuous load paths without being damaged during strong earthquake shaking. Otherwise, what you see in figure 4, the building will collapse. This is all about this earthquake tip number 25. You can download this tip from www.bmtpc.org. The next earthquake tip, that is tip number 26, will be on what harms load paths in buildings. Thank you.